Hi everybody, my name is Steve. Welcome to this video. Today we're going to discuss using switches to control servos through DCC EX. Previously I did a video on just basic servo control, turnout control with DCC EX using a PCA 9685. Now that strictly relied on software control using engine driver. You could use JMRI, you could use scripting to control it. In this video we're going to add switches. We're going to start off using toggle switches, mechanical switches, latching switches that hold position on or off. With that one, that's the only way to control it then. The switches takes over and the software methods won't work. The second part of the video, we're actually going to talk about using momentary switches where you can continue to use scripts or JMRI or engine driver or other software methods to control the switches as well. It's also going to be set up with LED indicators, so if you have a panel that you want to show the thrown or closed position, we're going to have that as well. So the video runs a bit longer than I expected it to, so as we go through it you can skip forward to some of the sections. The first part about the mechanical switches, like I said, it relies just on mechanical that way. So if you want to skip through that and go over to the momentary switches, that might not be a bad idea if that's what you want to have in mind. So jump ahead and save yourself some time. Just one thing to note, and I think I've noted a couple times through the video as I do this, when I was making the video I kept referring to Y throttle. In reality we're using engine driver. That's the Android-based throttle controller that allows you to control turnouts and routes and automations from within the throttle. So anytime I say Y throttle, think engine driver. So sit back and relax, and we're going to start with the toggle switches or the latching switches, and I hope you find this useful. Okay, here's what we've got going on today. We're going to start off with setting up toggle switches, or latching switches, I guess I should say. I'm going to actually use a rocker switch, but you can use toggle switches, rocker switches, or even push button switches that are latching push button switches. If you're not going to be using any kind of latching switch and you want to go directly to setting up for momentary switches, you can skip this section. Just go down to the description below, look at the time marks, and look for the section setting up momentary switches. You can skip ahead to that and save yourself some time and avoid this section of it. I'll recover everything that needs to go over in that section as well. Excuse me. Okay, so anyway, here we are with latching switches. We're going to be working with 3 servos today, controlled by a PCA 9685. We'll have 3 switches to control them, 3 LEDs to indicate the thrown or closed position, and DCC EX installed on an Arduino Mega. In this example today, we're just going to be using the header pins directly on the Arduino because we're only doing a few switches. If you've got a large layout, you've got lots of switches, lots of indicators, maybe signals, all sorts of other stuff, you're going to run out of pins pretty quick. So you'll want to add I/O expanders for sensing the inputs on the switches. You can also add additional PCA 9685s to drive the servos. They'll drive servos as well. I'm sorry, the LEDs, excuse me, LEDs. They'll drive them as well as the servos. I will be doing video on both of these. Check the description below. As soon as they're up, I will add a link to that in the description. So at the time you're looking at this, just look for the descriptions for I/O expanders and PCA 9685 for driving the LEDs. There already is going to be a link in there for the original video in this series on controlling LEDs with the PCA 9685, and in that one I go into the introduction on how to get these set up to work with DCC EX. Just one thing to look, since we are using the Mega in this case, we want to look at available pins, and I'm trying to be quick on this. This is available on DCC EX website. I will put a link to this in the description as well on how to link to it. But you want to avoid these pins labeled in red. These have to do with driving the motor shields, current sensing, and a few other things internal to the board, so we need to avoid those in red. The orange you can use, but you have to use with caution. An example is your transmit and receive pins for your serial communication. So if you've got serial devices that you're using those pins, then you need to avoid those. So basically the green pins are available. You can use those. The only thing to watch, although they are available for input-output, we're going to be using the SDA and the SCL, the clock and the data pins. Those are the I2C communication protocol for the PCA 9685. So if you're doing that, then you want to avoid pins 20 and 21, and also these two pins up at the top. Those are the same, also headers for the I2C, so avoid those. In our case, we're going to use 22, 23, and 24 for the LEDs, 45, 46, and 47 for sensing the switch positions. Okay, so to get this set up, we're going to be using Arduino IDE to upload the sketch to our Mega. I'm not going to go into the initial configuration of that. You should already have this set up and working on your system, as well as the initial setup of the PCA 9685s. If you don't have that, then go back to the first video, check out how to get that set up, and then you come back here to proceed with using switches. So if you remember from the first video, we created one of these tabs, one of these folders called myturnouts.h. And in it, we define our turnouts. We're doing servo turnout, uppercase servo underscore turnout. The first digit is just an identifying number. It's a label for the servo. The second digit is the actual pin number on the 9685. It's which pin on the board that it's using. The third number is the thrown position of the servo. The fourth position is the closed position. This fast, you're describing how fast you want the servo to move. You've got instant, fast, medium, or slow. For all of these, if you need additional help on what that means, go back to my first video on setting up servo turnouts, and I go into a little bit more detail about that. The last thing in here is the actual label for the turnouts. When it's got a label, it shows up in Y throttle with the push button that you can actually use to control the servo. However, since we're using a latching switch, it overrides that and makes these buttons useless. They don't do anything. So in our case, we want them hidden because there's no reason to have them since you can't use Y throttle to control them. So hidden hides them in there. I left one with the actual label on it just to show you what happens when we try and use it with the toggle switches. But typically you would hide the servos. Then if you remember, the other part we did was under My Automation. You have to include a # include in parentheses myturnouts.h. That basically tells the compiler when it compiles everything to go out to that folder, get those turnout definitions, and have them available to use. That's really all you have to have. The requirements is defining those turnouts to be able to use, so we can make our sketch to control the servos with the switches. However, when I do it, I like to use aliases. So it's giving names to things instead of trying to remember numbers and pin locations. So we're going to create a new tab. It's a new one of these tabs. And we're going to call it myaliases.h. And again, I'm uppercasing that first letter of the second word of aliases. Clicking OK, and you can see we're now in that tab, in that folder, myaliases.h. Now I've pre-written some aliases. I'm just going to paste here. This middle section here I have commented out. We'll get to that later when we get to the momentary switches. We don't need it for the toggle switches. So all I did was I gave an alias to the switches, pins 45, 46, and 47 like I covered earlier. We want to tell it, okay, we're giving it an alias. We're giving it a name. The name is switch 1, and its address is 45. We're doing the same for switch 2 and switch 3, pins 46 and 47. We're doing the same thing for the turnouts. Alias, we're giving it a name. The name is turn 1 for turnout 1, and the pin location is 116. If you remember from where we created the turnouts, the second number was the actual pin location on the 9685. That's what this is. You're telling it the address that alias refers to. Same thing with the LEDs. LED 1 is going to be on pin 22. LED 2 on 23 and LED 3 on 24. So we're just giving names to those pin numbers. That's all we're doing. Okay, so we go back to My Automation. Now we have to include that as well. So # include parentheses myaliases.h, close the parentheses. And so now it'll do the same thing. It'll go out and get that information and have it available for the sketch. Now we're ready to write the script. Now this too, I have kind of pre-written the sequence I need for it, so I'm going to copy and paste it just to speed things up a little bit. Okay, So a little further in the video, when we get to momentary switches, I'm going to go into a little bit more detail about the difference between sequence versus automation versus root. But just briefly, a sequence is an automation routine that does not appear in Y throttle. It hides it. It's back there running, or can be running, but it's not visible. You can't start it and stop it yourself because there's no button. Because of that, and you have to give it a unique number. Every sequence, every automation, every root has a unique number, and these numbers cannot be duplicated even between sequence and automations. So if you have sequence 1, you cannot have automation 1 or route 1. Each one has to have a unique number. We're using this auto start command, so when you start DCC EX, this tells it to automatically run this sequence, run this script. Because since it's operating in the background and you want those switches always to be available, you need to tell it to start every time. Okay, so now we tell it what to do. So we're telling it if switch 1. All that means is that if you flip switch 1, if you turn on switch 1, then do what comes next, which is throw turnout 1. So if switch 1 is on, throw turnout 1, set LED 1. That just means setting pin 22 to high, which turns on the LED. So if switch 1 is on, throw the turnout, turn on the LED. Else, if the switch 1 is not thrown, that means the switch is in the closed position, then we want to close the turnout. So close turnout 1, reset the LED, which sets it to low, turns off the LED. Every if command needs to end with an end if. So that's our little script for getting the switch to run. If switch 1 is on, throw, turn on. Else, if the switch is closed, close the turnout, turn off the LED, and that's it. We do the same thing for switch 2 and switch 3. So all 3 of those switches for all 3 of those servos we've got are ready to go. The only thing you need to add at the end is this follow 01. All that does is tell the sequence to go back and start over again. So it's just repeating through, continuously following the sequence, sensing for those switches to see if you flip them or not. That's it. That's all there is to it. This will make the switches work. So what's next? We upload it to the Arduino. Okay, so we've got our tools, we've got our board loaded, we've got our COM port selected. So we're going to upload. That's this arrow here. It compiles the sketch. Takes just a minute to do that. Now it's uploading the sketch to the Arduino Mega. Okay, it's done. It's loaded onto the Mega. It's ready to go. So we're going to switch over to an actual video camera view and do a demo, show how we got it hooked up, wired up, and a demo of the switches in operation. All right, we're ready to show how it works with our latching switches. So we've got our 3 servos connected to our PCA 9865, kind of in the back there. There's a power cord going on the wall with a 5 volt power supply connected to drive the servos. Underneath here is my Arduino Mega. So I've got my I2C connector going to the PCA 9685, and here's my switches, my toggle switches, or rocker switches in this case, with the LEDs. It's just a little mount that I made to hold them, a little 3D printed just to hold them in place. They're all connected with the resistors on the back side of it to hold everything in place. So we're just about ready. Let's give it a shot. So if we flip the switch, we get our indicator and the servo moves for driving your turnouts. So they're showing your turnouts in the closed position. And there you have it. That's all there is to it. Now, I did talk about in Y throttle that you still can label the throttle. We did on that one sample to show this, and it doesn't matter what you do. I can push it, nothing happens, because this switch position is overriding it. Being locked in the off position, there's just nothing for it to sense, and it overrides it. However, it will show, so if I flip that switch, it'll show it closing, throwing and closing, but you can't control it. It doesn't do anything. So that's why we hide them in here. They don't really do anything except for take up space. So that's it for the latching, toggle control type turnout switches. And next we're going to go ahead and go on to using momentary switches. And the benefit for you doing it that route with the momentary switches, you'll be able to control the switches. You'll be able to control them with your Y throttle. You'll be able to control them with pre-written scripts in your automation file. You can control them with JMRI, and in every case, it will indicate the LEDs when it's in the throw position, and you'll still be able to adjust it as you want. So we'll continue on with that next. All right, moving on, let's get to controlling it with momentary switches and what it adds. If you watch through the first portion of the video with doing it with latching switches, I'm going to be repeating myself on some of this in case you skipped over and came straight to the momentary switch. There's some information I need to share. So sorry if it's a duplicate for some of you. But in this scenario, we're going to be, in this demo, 3 servos for the turnouts, driven by a PCA 9685. The 3 momentary switches, and the 3 LEDs, which will indicate the thrown or closed position. DCC EX installed on a Mega. And in this example, because we're just using a few turnouts and switches, we're going to actually use the pins directly off of the Arduino Mega. If you're doing a large layout with lots of switches or lots of LEDs, you'll run out of pins and you need to add to it. So you can add I/O expanders, or you can use additional PCA 9685s to drive LEDs as well as the servos. So I'm working on videos for both of those. Watch in the description below. Once I get it done, I'll have it posted in the description. Links to the video on adding I/O expanders and adding PCA 9685 to control LEDs. I've already added the link below for controlling the servos with the PCA 9685. That was the first video I did in this series. So if you're just getting started, need help with that, watch that one first and then come back here on installing the push buttons. Okay, so back to the sketch. We're using Arduino IDE to be able to upload the sketch to the Mega. In the first video we did on controlling the PCA 9685, you remember that we made the My Turnouts folder for defining the turnouts. Let's go back and look at that here. So for today, with the latching switches, for those of you who watched the first part, know that we hid those buttons because with the latching, it doesn't have any purpose in showing up anywhere else, such as in Y throttle. Well, now we're going to the momentary. We want that back. So we're defining our turnouts here, and we're going to give them all identifiers. Let me just change these real quick. Okay, so if you remember from the first video, we defined our turnouts. Uppercase servo underscore turnout. The first set of digits is to label or identify the turnout. The second numbers are the actual pin on the PCA 9685 that drives it. The third digit is the thrown position. The fourth digits are the closed position. Then the speed of the turnout. You've got instant, fast, medium, or slow. And then this is the label. This is what actually appears in Y throttle for your turnouts. And I'm just using servo names, servo 1, 2, and 3 for this example. But you can create whatever name that you want there. So that's got the servos defined and ready to go. Then back in automation, again, if you remember from the first video, we have to include that into the My Automation file. So pound include, in parentheses, myturnouts.h. Now, in the first part of the video, you saw where I created aliases to give names to everything. So all this is include the myaliases.h as well. And it's just another one of these tabs that I created, and it's down here. We need to make some change to it, though. So for this demonstration, and here's where things start to get a little tricky. If you think about the latching switch, when you throw the switch, it latches to the on position. So as long as that switch is in the on position, Arduino Mega senses that. Then when you flip the switch back to the off position, it's no longer getting that signal that is on, so it senses that as well. If you think about a momentary switch, only as long as you are holding the button does it sense it in the on position. But you want to be able to latch the turnouts in the open or thrown or closed position, and that's done by latching the switch in the on or off position. So to do that, we're going to make a virtual switch. And through some of the programming, we'll be able to tell the virtual switch to latch either on or off. So that's what this alias is here. We're making the virtual switches. We're telling it, we're giving it an alias, we're giving it a name. The name is switch 1 check. Again, you can use whatever name you want. We're just using that name for this example. Now the address, since it's a virtual switch, it needs to be something that does not exist in hardware. By that I mean the Mega has 53 I/O pins. We want to switch beyond those numbers, or it's somewhere in the range of numbers that the Mega doesn't use. So we're going to use in the 60s in this example, 61, 62, and 63 for our 3 virtual switches. It's basically just setting an address so you can fool it into thinking there's a switch that's on or off. If you're using I/O expanders, just be careful because you have addresses that you assign to the I/O expanders, and your virtual addresses need to be something that does not exist anywhere in that hardware. So that's the thing to watch. These need to be software-only switches, sensors, basically. Everything else is the same, and for those who weren't there for the first part, we're just giving names to stuff instead of having, so that when we write the script, we don't have to remember numbers, what's where. So we're giving everything an alias, a name. So alias says, hey, we're giving something a name. Then what is the name? In this case, switch 1, and then we're giving it an address. And in this case, 45. That's the Arduino pin 45. So switch 1 will be read on pin 45. Switch 2 on 46. Switch 3 on 47. The turnouts, remember we assigned them addresses when we define them with their pin number on the PCA 9685. Well, I'm also giving it an alias, a name. So alias, give it a name. What is the name? Turn 1 for turnout 1. What is the address? Pin 160. Finally, same thing for the LEDs. Alias, give it a name. What is the name? LED 1. What is the address? Pin 22. That's pins 22, 23, and 24 on the Mega for driving the LEDs. So that's our aliases set up. I know that this is a new part and it may seem kind of confusing. Hopefully as we go further it will get better defined. So we'll go back to my automation, and again we include those aliases also so it is available to the sketch. This is the sequence we did for the latching switches. We're not going to use that in this example, so we're just going to take that out. I do have a sequence that I need, the sequences that I need already written. I'm just going to copy and paste these to speed things up a little bit. Okay, so let's look at what we got with these sequences. Again, if you missed the first part of the video, sequence is an automation that does not appear in Y throttle. It doesn't give it a label, it doesn't give it a start button, it's just there working in the background. Every automation needs a unique ID number. In this case, we're going to use 02. That cannot be shared between sequence, automation, or roots. Each one has to have its own unique number. So since there's sequence 02, if I do an automation or a root, it has to be some number different than 02. Basically what this means is that when you're doing these automations, the number here, the 02 in this case, is what actually identifies it to DCC EX and which one that it is. The first portion of it, where there is a sequence, an automation, or a root, handles it a little bit different in that in the case of the sequence, it does not appear in Y throttle. So there's no button to start it or anything. So that's where we're doing the sequences because we want this to run all the time in the background. We're looking for the switches to be activated. So to do that, every time DCC EX runs, we want this to run as well. So that's what this auto start command is. When DCC EX starts, it'll start this sequence. Okay? So now let's go through with what we're doing. We're doing this if command, if thrown, turn 1. So if you remember in our aliases, turn 1 means turn out number 1 on pin 116. If it's thrown, so if it's in the thrown position, that would mean this is a yes. If thrown, turn out 1, yes. Well, then we want to latch that virtual switch we made. We want to tell it that that virtual switch we made is in the on position. Because if you remember from the first examples we did with the latching switches, the toggle switches, when you'd flip that toggle switch on, it stays on because it's a latching switch and it would throw the turnout. Well, since we're using momentary switches and you don't have that latching position, this is what the virtual switch is for. We're creating this fake switch to record whether the turnout is thrown or closed, basically. So turnout 1 is thrown, is in the thrown position, latch, switch 1, check, turn it on. Also, turn on LED. Set means set the pin to high, which turns on the LED. Else, if the switch is not thrown, so that means if the switch is in the closed position, basically. So if it's not thrown, then we want to unlatch that switch check. So that's our virtual switch. Again, it's like using the toggle switch, except for doing it in reverse. When the switch is thrown, it locks the virtual switch. It also resets the LED, turns it off, sets it to low. Okay? So again, since it's an if command, we end it with an end if. And I'm adding the set, turning on the LED and turning off the LED here. So anytime the switch gets thrown or gets closed, it controls the LED as well. So this way, it doesn't matter if you use JMRI, if you use Y throttle, or if you use your momentary switch. Anytime that switch gets thrown, the LED will match, so your panel can show the correct position of the switch. Okay, I hope that makes sense. So we're doing it for turnout 1, turnout 2, and turnout 3. Just the same command, just based on the different switch position. Okay, and then at the end, we're using our follow command, which tells DCC EX to basically the continuous loop. You get to the end of this, follow command or follow script 02, it goes back to this and starts over again. So it's just looping through sequence 2 over and over again, watching for the turnouts. All right, let's go on to the next one. The first thing I want to cover is that our next sequence is going to be called sequence 3. You can have multiple sequences running at the same time. So we've got the first one set to auto start that watches for the throw or close position of the turnouts, and it runs continuously. The next sequence is going to watch for when you actually push the button on the switch, the momentary switch. We're going to auto start that one. It's going to loop through and run continuously as well. So both of these can run at the same time. And so what we're going to do is we're going to test for that momentary switch when you push it and release it. And we're going to use some nested if commands to determine what happens. So the first if command, if switch 1, that means if you've pressed switch 1 and it's on. Okay, well, what happens next? Yes, you've pressed it. Well, we want to check the virtual switch. Is it on or off? Okay, if the switch is on, that means the turnout is thrown, because if you remember in the first portion, when the turnout is thrown, we latch that virtual switch or we turn it on. Okay, so the switch is on, that means the turnout is thrown. We've pushed the button because we want to do something. What do we want to do? Well, we want to close the switch. Well, there we go. Close turnout 1. And remember, we're just using the aliases, and what it does just sends the command close to pin 116 in this case. Else, now this else command replies or is in reference to the second if statement. So if switch check 1 is not latched, okay, so remember here, if it's unlatched because the turnout is in the closed position. All right, I hope that makes sense. So the virtual switch is not latched. The turnout is in the closed position. We've pushed the button because we want to throw it. So we do that. We throw turnout 1. Okay, now if you remember, every if statement has to have an end if. So this first end if ends the second if statement, and the second end if ends the first if statement. Okay, so if, everything in between that happens, end if. The second if, everything in between that happens, and then end if. That's why they're in that position. And you do that for all 3 switches. And so that just says, if you push the button, do we throw or close the switch? Okay. Now, if you think about it, you're using a momentary switch, and the processor on these Arduinos, although they may not be the fastest computers in the world, they still will work faster than your finger. So you need to delay just a little bit to give yourself time to press the button and let it go. Because otherwise, and I'll demonstrate this, if you press the button and you're holding it, then it reads multiple readings of whether the switch is open or closed. You just get multiple readings of it. So we want to delay. In this case, 250 is a quarter of a second. This is milliseconds. So delay 250 is a quarter of a second. I have found that works fine, it seems like, in most situations. You may have to experiment with that. If you're really slow at pushing and releasing the button, you may need to increase that, to a third of a second or half a second. I could see it even going as far as a full second. You just have to wait that long between each pushings of the button. In general, I find that 250 seems to be working okay. And then the last command is the follow 03, which again just tells it to re-loop back through the sequence and run it over and over and over again. So that will, excuse me, read your buttons, throw your switches, and have you ready to go. So the next 2 parts of this, and I'm just going to show you because this is what I'm doing just for the demo to make it work. This automation, and it's got number 04. Now in this case, you see we've got an additional argument to it. We're adding a name to it, a label. This is actually going to appear in Y throttle with the button where you can start this automation. And this one, all it does is throw and close the turnout every 5 seconds. So I'm just doing this so that I can demonstrate that even if it's DCC EX doing the commands, you'll still see the results happen with your LED and what happens when you push the button and everything works. So this is just a little script to throw and close the servos every 5 seconds. So per second, it will continue to run. That's what the follow command is. It will come back and just loop through over and over again. The other part is a root. Again, this is going to have a button in Y throttle. It's number 5, and I've labeled it, again, set turnouts. You're giving it a name. When you push the button, it's going to throw turnout 1, throw turnout 2, and close turnout 3. And you might use roots in your switching yard. If you have predefined roots, you want to press one button and it sets all the roots to get your train from the main line to whatever switching line you want it to be. It will do that. You want that to run only once. So we don't want it to follow. We don't want it to come up and do it over and over and over again. We want it to only do it once. So at the end, that's what the done command is instead of a follow. Run once and stop. All right, so that's everything we need to make it work. Hopefully that makes some sense. We're going to demo it now and see how it works. So what we need to do is just upload it to the Arduino. I've already got it hooked up on my port 6, and this arrow uploads it. It's going to compile it. Should just take a moment. Uploading it, and then once it uploads, we'll be able to check it out on the demo. Okay, it's done uploading. So now we're going to switch back to the video camera to be able to show a demo of what this is and how it works. Okay, welcome back. We're ready to demonstrate our momentary switches and how they work with the system. So we've got our 3 servos connected to the PCA 9685 in the back. It's got a 5-volt power supply that drives the servos. Underneath this green board is our Arduino Mega. This is just a terminal board that I've got that I have made up with screw terminals for making connections to. It just makes it a little bit easier. Then we've got our 3 momentary switches with the 3 LEDs to indicate the open, thrown or closed position. And then it's all wired up based on that diagram that I showed you earlier with the pins to where they need to go. We also have our Y throttle on this little phone here. And we'll get to that in just a second and show what it does. Okay, so we're set up and it's all working, and basically the way it should be is when we push the buttons, it throws the servo and lights up the button that goes with it. Now, you may see a little hesitation or the buttons don't work that great. These are some kind of cheap little momentary buttons, but they're small size and fit on this little panel, so that's why I use them. I've got better buttons that work better, but these are working for this example. But anyway, as you can see, as you press the button on or off, it controls the servos. Okay, so let's see what that looks like in Y throttle. So we go to our turnouts, and you can see the 3 servos. Okay, so they're in the closed position. It says throw because when you push it, that's what you want it to do. You want it to throw. So that means they're all in the closed position. So if we do press it, okay, you can see it moves the servo, it lights up the LED, and it updates the little screen. So we can do that for all 3. And it controls them, okay? So if we do it here, you can see it also updates on the screen. So each of these, as I close them, it updates the Y throttle, and everything else updates the LEDs, the servos. All right, so that's what we wanted, right? Okay, just talking about the delay we put in for pushing the momentary switches. I've actually gone back and removed that delay just to kind of show you why you want it, what happens if you don't have it. So if you remember, when you're pushing a momentary switch, it's constantly reading it, so you can kind of see how things are twittering around, and it gets confused, because even just trying to press the button, your finger doesn't move fast enough to stop it. So you need just a little bit of delay on those buttons to make it work smoothly. Now, I also mentioned in the earlier section, I was talking about roots and automations. So under this roots button here, the first thing we've got this R5, the R is for roots, set the turnouts. And if you remember that, when we set it, it was to throw the first 2 turnouts and close the 3rd one. Maybe you've got a predefined route. You've gone from the main line into a switching yard, and that's how you would get to that yard. You can predefine it. You can give it names. I used set turnouts when we were identifying that. But when you operate it, okay, you see it moved all 3 servos to the position they were supposed to go to, and again updated the LEDs. Okay. Now, the other thing we talked about was the automation, and I was writing that little script that every 5 seconds was going to change the position of the servo, of a turnout. Now, I didn't auto start it because I wanted to be able to go through this and show you what's going on, but now that I'm ready, so we're going to start this, and every 5 seconds it's going to start changing the servos. There we go. There's the first one. And as it's doing that, we'll come back to the turnout screen, and you can see these will update as it goes through its routine. The LEDs update, the screen updates to show what's happening. So everything communicates with each other and does what it's supposed to do. And since you're in here, you can also still come in and override the script. So you can tell it to do it, and of course everything updates. Same here too. If you still come in here, it still controls the servos. The only thing to be careful is you've got an automated script running, you have trains running, and you've got switches set, and that automated script is changing these turnouts for your trains to run through. If you come in and override it, you could be setting yourself up for an accident or a derailment or something. So it is available, it is there, and certainly there are reasons why you might want to do this, but just be careful when you override whatever you have written in your automation script if you're using that. Well, that's it. Setting up and using switches, or switches, push buttons to control your turnouts with DCC EX. I hope this is helpful for you. I know it ran a little bit long. I didn't intend it to go that long, but things just seem to pile up when we're trying to give a good explanation. I hope you enjoyed it. We'll have more videos coming up, so please keep checking back here. We'll have new things once in a while, and hopefully some extra tips to help you set up your DCC EX and your train layout. Thanks for joining.